Deep learning is a specific method of machine learning that incorporates neural networks in successive layers in order to learn from data in an iterative manner. Deep learning is especially useful when you are trying to learn patterns from unstructured data. Complex neural networks are designed to emulate how the human brain works, so computers can be trained to deal with abstractions and problems that are poorly defined. The average 5-year-old child can easily recognize the difference between his teacher's and his mother's face. In contrast, the computer has to do a lot of work to figure out who is who. Neural networks and deep learning are often used in image recognition, speech, and computer vision applications. But how do we mimic the human brain? In order to understand neural networks, first we need to understand the perceptron algorithm. Let's turn back to our friend's analysis, who works in the credit approval department. He made a plot putting the relation of customers' credit score versus the loan amount the customer applied for and checked if they were approved or denied. In order to make it easier to understand, let's scale the both axes from 0 to 10. Here we need to do some math. The boundary line has an equation of 3 times credit score minus 2 times the loan amount minus 4. What does this mean? It means that when a new application comes in, we put the values of the application to this function and take the score. If the final score is positive, we approve the application. If the result is negative, then we reject it. This is called a prediction. This linear equation is our model. We could have more features to put into the equation, but in this case, the model would be in a higher dimension and we wouldn't be able to visualize it. But that wouldn't be a problem for our model and we still would have a prediction. Now let's use the notion for the perceptron, which is the building block for neural networks. Here, you can see our data and the boundary line. We will fit it inside a node. Now we add the small nodes for the inputs, which are the credit score and the loan amount. The numbers we use to multiply our features are the weights, and this number is called bias. The label or the prediction is 0 if we reject it, and 1 if we approve it. The green points have a label of 1 and the red points have a label of 0. The goal of the algorithm is to make predictions as closely as to the real result, which is exactly the same as finding the boundary line that keeps most of the green points on this side and red points on this side. Our node only produces 0 or 1. Note that inside the node, we are using an implicit function which is called a step function. What step function does is that it returns a 0 if the input is negative and 1 if the input is positive or 0. So these perceptrons can be seen as a combination of nodes where the first node calculates the linear equation and the inputs on the weights, and the second node applies the step function to the result. There can be different step functions with different behaviors, but that's not important for now. In a press conference organized by the US Navy in 1958, Frank Rosenblatt made statements about the perceptron that caused a heated controversy among the fledgling AI community. Based on Rosenblatt's statements, the New York Times reported the perceptron to be the embryo of an electronic computer that the Navy expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. Although the perceptrons initially seemed promising, it was quickly proved that perceptrons could not be trained to recognize many classes of patterns. This caused the field of neural network research to stagnate for many years before it was realized that a feed-forward neural network with 2 or more layers, also called as multilayer perceptron, had greater processing power than perceptrons with 1 layer. In practice, neural networks used today are much larger with easily thousands, tens of thousands, or even much larger than that numbers of neurons. They are built with many hidden layers and different architectures for different purposes. One of the wonderful things about using neural networks is that to train a neural network, in other words, to build a machine learning system using neural network, all you have to do is give it the input and the output, and it figures out all of the things in the middle by itself. So to build a neural network, what you would do is feed it with lots of data and have a neural network architecture looks like this one. And it's the software's job to figure out what these neurons should be computing so that it can completely automatically learn the most accurate possible function mapping from the input to the output. And it turns out that if you give it enough data and train a neural network that is big enough, it can do an incredibly good job mapping from inputs to outputs. So a neural network is a group of artificial neurons, each of which computes a relatively simple function. But when you stack enough of them together like Lego bricks, they can compute incredibly complicated functions that give you very accurate mappings from the input to the output.